Okay, let's have a look at how to differentiate. So what we're going to do is go through it step by step, so it's very clear. If you're unclear about any of the steps, I need you to make contact with me. I need you to email me, say, look, can't do step 3, can't do step 1, can't do step 5. Okay, really important, okay. So the first step, step 1. Step 1 is to state the function, right? So we're going to state the function, we're going to write out the function. All right, how do we do that? So let's say, for example, the function is y is equal to 2x squared plus 3. That's what we write down. So that's what I mean by state the function. In other words, write down the question. Question number 2. Let's look at the x's and look at the y. We're going to change this side and we're going to change this side. The bit on the left here, the y bit, we're going to write dy dx. That means we're going to differentiate y with respect to x. Or you could say, let's look at the difference in y with respect to the difference in x. Or the change in y with respect to the change in x. Because we're going to change x and we're going to change, as a result, y. So let's see how that plays out. So to do that, we take the coefficient of the x and multiply it by the power. So multiply the coefficients of x by their respective powers. So, what does that mean? Well, let's say I've got 2x squared. 2 is the coefficient, it's the thing in front of the x, and its power is 2. So this is going to be 2 times 2. 2 times 2 is 4. So we write a 4 and we write the x again. Now, I'll call this A. B is, we're going to reduce the power by 1. Reduce the power, or powers, there's a whole bunch of them, by 1. So in this case, this is to the power of 2. We're going to take 1 off that 2, so it's going to become a 1. So it's 4x to the 1, but 4x to the 1 is just 4x, so I'm just going to leave that. Now, step 3. Any constants, they're things that do not change. In other words, the x here will change and the y will change as these two increase or decrease. But the 3 will remain exactly as it is. This is a constant. So we're going to any constants fall away. In other words, we can just cross them out. So in this case, the 3 here, we're literally just as if we're putting a cross through it. And so our differential is going to be, dy dx is going to be 4x. And that's how we differentiate. Now I'm going to apply these principles to a whole bunch, and again, get you to have a go at doing these. You'll also notice some different ways of expressing a function. So for example, let's say the function is not y is equal to, let's say, 3x cubed plus 2x squared minus 4. Let's say it's f of x is equal to 3x squared, or sorry, cubed in this case, plus 2x squared minus 4. Rather than saying d, you could say for this, you could say dy dx. Here you would say f prime f. So f prime x. It means exactly the same thing. And of course, again, we're going to go 3 times 3 is 9. X, reduce the power by 1 becomes a 2. Add it to 2 times 2 is 4. X, reduce the power by 1 becomes 4 to the 1, which is just 4 times x to the 1, which is 4x. And we're going to let the constant fall away. So there is our differential. That is all you need to do.